So welcome on my part. My name is Antti Lehmussola. I'm working at CSC in Finland, and CSC is the Finnish National Competence Center in this EuroHPC project. So EU is funding big computers, and through these projects they try to make it easier and facilitate the use of these resources in businesses, in commercial activities, innovation and research. And this is one of the actions that we have taken now, together with the Estonian National Competence Center, where Ülar Allas is the representative from there, that we try to disseminate, we try to tell you that what benefits and advantages there are, and then we would like to engage with you in any discussion that what your interests would be and how we could help with those. We would like this event to be as interactive as possible. We have set up introductory talks. In the first part, there is Ülar telling about the, in general, how the HPC, how this significant capacity could be used, and how it could be useful for your businesses, and also present the Estonian National Competence Center and the resources there. It's followed up by maybe I scroll down a little bit on the screen. So here is the program, followed by Markus Lippus from MindTitan company with an actual use case, how they've used the computing capacity. Unfortunately, Mark Fiesel is not with us today. He had other urgent matters to attend to. And then we had scheduled a small break, but if all the presenters are ready, Dan is here, and then if Sakari is here as well, and if Antti Lehmussola also is here, then we could maybe start the second session a little bit earlier than at 10. Depending on how the lecturers want this, or the presenters, you can of course give any instructions or guidance what you want, but I would propose that if you have questions during the talk, those could be written in the chat box and then taken after the talk. And after the talk, of course, it's open discussion, so you can just open the mic and pose any questions. As I said, we'd like to have this as an interactive event, so discussion is encouraged. If this raises any questions that you're interested in, then please contact us afterwards, and then we can go into detail on how we could help you. Either please contact Ülar in Estonia, or then Dan still in Finland.
Hello, good morning, everyone. Thank you for joining our webinar. I've got roughly 20 or 25 minutes to talk about the added value that the HPC can provide to the SMEs companies. So let's get started. If you have any questions, then I think you may also write them into chat, and we'll definitely answer them later. So we live in the world where more and more data is being created every day, and it is not easy to handle such huge amounts of data. And so this is where high-performance computing can assist. High-performance computing, or HPC, refers to the technology that enables to process huge amounts of data at high speed. So this is why HPC is nowadays extremely important. HPC is the key behind discoveries and innovations that improve people's quality of life. The best well-known HPC solution is the supercomputer. Supercomputers are millions of times faster than ordinary computers. Therefore, they can be used to quickly solve tasks that would take a very, very long time on an ordinary computer to solve. It's all about speed. A supercomputer is made up of thousands of compute nodes that function together as one. This means that while an ordinary computer is like a single violin, a supercomputer is like a symphony orchestra. Another difference between an ordinary computer and a supercomputer is that an ordinary computer can operate only a single task at a time, and this is called serial processing. A supercomputer, however, works much more quickly by splitting problems into pieces and working on many pieces at once. Such an approach is called parallel processing. So parallel processing is one of the reasons why supercomputers can perform extremely complex computational work very quickly. Now, it might be interesting to know what are the fastest supercomputers in the world and where they are located. This information is summarized in the top 500 list that contains details on the 500 fastest supercomputers in the world. According to the last issue of top 500 list, the world's fastest supercomputer is called Fugaku, and it is located in Japan. But the most interesting thing is that approximately 65% of the top 500 supercomputers are located in China or in the United States. The more supercomputers a country owns, the stronger is the country's economy. And that is the reason why countries are always trying to create faster and faster supercomputers. The biggest myth in the HPC world is the opinion that HPC is meant only for universities, researchers, and very large corporations. The reality is that supercomputers can be used in all industries where data collection and analysis is involved. Even small companies with, for instance, 5 employees can take advantage of HPC solutions. According to studies conducted in the United States, every dollar invested in HPC results is an average revenue of $463. Large companies already use HPC a lot because it is the key to innovation and success. SMEs, on the other hand, are less active HPC users, but it has been estimated that there are more than 140,000 potential SMEs in Europe that could use HPC. It turns out that there are 2 main reasons why SMEs make little use of HPC. The first reason is that SMEs are not aware of HPC possibilities. And the second reason is that SMEs are not fully convinced on the benefits of HPC. The number of industries that can benefit from HPC is growing very rapidly because a lot of companies are exposed to huge amount of data. HPC is the only reasonable solution for handling massive amounts of data. It is really not for rocket scientists anymore. Here's a list of some industries that are most often using HPC solutions. Manufacturing and engineering are understandable fields, but fields such as retail, banking, financial technology, and insurance have also adopted HPC technologies. Healthcare companies need HPC for medical data processing and drug research. HPC is also essential for urban planning and national defense. Movie industry uses HPC for creating special effects, and this list with examples is expanding fast. So the faster you start using HPC, the better for your business. On this slide, I have listed the primary benefits that the HPC can provide to companies. First, reduced physical testing. Engineering companies can use HPC to replace physical prototypes with realistic simulations. Simulations are less expensive to study when compared to physical prototypes. Then speed. HPC enables to perform massive calculations in a short time. As a result, companies that use HPC can bring their products faster to the market. Reduced research and development costs. Faster answers mean less wasted money and time. HPC simulations enable to detect errors in early stages of product development. And of course, early detected errors are much cheaper to overcome. And finally, innovation. As technologies like the Internet of Things and artificial intelligence evolve, the amount of data that companies need to handle is growing very fast. HPC is the force that drives innovation across nearly every industry. And in short, HPC enables companies to do more while spending less. Here we have the results of a study that was conducted recently in the United States. Companies that were already adopted HPC were asked to reveal the main reason why they are using HPC. And it turned out that the main reason for preferring HPC is the speed, as HPC enables fast solutions. Second reason to use HPC is that companies were unable to solve the problems by any other means. According to the same study, majority of the companies that employed HPC agreed that HPC is essential for their ability to innovate, compete, and survive. They also agreed that HPC significantly speeds up R&D process, and they also agreed that HPC is the only practical solution for some problems. And HPC is critical to the future direction of their business. It is clear that SMEs are the backbone of the European economy. For that reason, the European Union is trying to encourage SMEs to discover what HPC is and how to take advantage of its opportunities. Every European country has now its own national competence center that acts as the central point of contact for HPC and related technologies. The missions of National Competence Center are to provide HPC related expertise for industry and academia, to offer HPC trainings, and to foster the industrial uptake of HPC. It is important to understand that SMEs do not have to build their own supercomputer because they can use the existing national HPC infrastructure. And in that case, they pay only what they use. So even small companies and startups can afford HPC services. In Estonia, we have 3 major HPC service providers. The largest is the HPC Center of the University of Tartu. This HPC Center provides computing resources, data storage, and user support for both academia and commercial users. So everyone is welcome. And for larger projects, Estonian users can also apply for LUMI supercomputer. My colleagues from Finland will later talk more about LUMI supercomputer. It really is a wonderful machine. Maybe someone of you is wondering, when is the right time to start using HPC solutions? And there are 2 answers. First, when your own computer runs out of space. And second, if you are in a hurry, then you can consider the HPC opportunities. The HPC Center of the University of Tartu currently hosts two computing clusters. One of them is called Rocket. This cluster contains approximately 10,000 cores. And in addition to that, there is another cluster which is meant for projects that require a lot of memory. This machine is called Atlas. So next important question, how expensive it is to use HPC services. I have a table here that summarizes the prices for the services offered by the HPC Center of the University of Tartu. And as you can see, the prices are not expensive. For instance, using 1 hour of one CPU core will cost only approximately 1.5 cents. Using 1 hour of GPU or graphics processing unit costs only 5 cents. Maybe in the beginning, it's a bit difficult for you to decide whether you need CPU or GPU. GPU acts as a sort of accelerator in the supercomputer, and it is sometimes a better choice, but not always. It really depends on the type of project you are working on. And our specialist definitely will help you to decide whether you need CPU or GPU. And in addition, we also offer a free proof of concept period for new projects. During this free period, you can figure out whether the HPC solution that you have chosen is suitable for you and whether you want to continue with the project or not. When we compare our local HPC services with the commercial service providers such as Amazon, Google, or Microsoft, then my opinion is that there are several reasons that can make our services more attractive. First, which I think is extremely important, our users have a complete overview of what happens to their data. This means that our HPC solutions are also suitable for the secure processing of sensitive data and for storage of sensitive data. With commercial cloud providers, unfortunately, you can't be absolutely sure what they are actually doing with your data. Maybe they are using it for some machine learning projects. You can never be sure. Second, our prices are definitely competitive, and usually our prices are cheaper. And finally, we provide fast user support. For instance, we can help with software installation, which helps you to save time. And it's always easier to solve problems when user support is located in the same country as you are. Now, how can companies start using HPC in Estonia? First, the companies should have an idea of what they want to achieve. It's a good idea to read success stories and explore what other companies have done so far. Then, if you already have an idea, then you can contact the Estonian HPC Competence Center, and the Competence Center can offer you an access to national HPC resources. It is probably the easiest way to get the access. Or if you are a manufacturing company, you can contact the Estonian Artificial Intelligence and Robotics Hub, EIRE, and ask for advice. EIRE is specialized on artificial intelligence and robotics solutions, and it's their job to help you. You may also think about using the industry collaboration services provided by Estonian universities. Anyway, all these channels will open you an access to Estonian HPC resources. Finally, I would like to share with you some Estonian HPC use cases that have been successful. For instance, the Estonian Land Board has developed a three-dimensional map application that enables to obtain a view of all buildings across Estonia. Another example is the development of public sector machine translation technology. And the final example here is the development of autonomous driving technologies. Thank you very much for your time, and don't hesitate to contact me if you have any questions. Thank you.
Hello, everyone, and thanks for coming and listening to me. So I'll be talking to you about the image-based diagnostic system. So we're also currently in the process of developing speech recognition systems on Tartu University's HPC. But because like this one isn't completely finished yet, then I'm bringing this specific use case to you. So I'll talk a bit about like just what we are, or why am I even talking to you, or why you should pay attention to anything I have to say. So what MindTitan does is basically we help other people with their machine learning problems. So we're an agency focused on machine learning. And we work on all kinds of different problems, doing completely bespoke solutions, and we have a few products in our portfolio as well. But mainly we're focused on turnkey AI solutions. Different companies, different clients require different parts of the whole system. We do anything from idea validation to actual deployment and scaling. And we work on like getting custom AI solutions in a lot of different areas, from NLP to computer vision, which I'll be talking about today, but also like recommendation engines or human in the loop systems. We have a reasonably good track record, very high success rates, multiple of our clients. Most of our clients are still using the solutions that we develop for them, also working in the private and public sector. And we have projects all around the world, as the industry is fairly popular these days, and getting more popular as we go. But yeah, so on to the project. So what I'm talking about is automatic full discovery for energy sector. We're talking about a company that is basically diagnosing the power lines of power transmission companies. And like usually how you do that is that people either well, they used to drive around and look at the situation on the ground and decide which pieces need to be switched out. Either it's the insulators, the cables, there's some plant growth that needs to be removed, or maybe the posts need to be replaced completely. And now it's got a bit more automatic in the sense that, or like a bit more streamlined in the sense that usually people fly over those lines with drones, take a lot of photos, and then those photos are analyzed later on by specialists. But there are a lot of images, and looking over all of them, it takes immense amount of time for specialists. A few examples of the images that we're working with. I didn't specifically choose difficult images, but you can see that images are from varying angles. The objects we're looking at are quite far away, and there are a lot of complications in these images, meaning that there are a lot of details that we don't really care about simply in the environment itself. Now, what the machine would have to do is to locate everything that is of interest to us and detect if it's faulty or if there are any other potential issues with that. So the solution here would be that there is an AI system which scans all the images that are taken and suggests what the issues could be with different components. Again, like if you look at those images, we're not talking just about insulators, but like every component of these masts and everything that's directly around them could be a potential issue. So a lot of different objects to understand and a lot of different scales to operate on. But in essence, the solution here, the machine learning solution would also be a human in the loop system. You have drone footage. These are fed into a machine learning algorithm that finds what is potentially broken or what has issues or what is going to be broken soon. We're trying to also notice wear and tear and if there's like environmental contamination on those images. Then a human looks at those flagged images and decides if it's an actual issue or not. This also means that we have to. It's better to have false positives than false negatives. Everything that the human, because the human has to check everything anyway, then everything the human checks will be stored as labels. They go back into training data, which is again used to train the machine learning models. And with the actual faults, a technician is sent out to repair those faults. If we look at the details of this issue, is that the source data is strong glitch. With some companies, it's easier to like implement a specific process where drones make images from specific angles and specific distances, but usually that's not the case. So people just fly over the power lines and take as many images as they want to, and at a very different angles and distances. About 200 images per kilometer. What's another challenge for the machine learning system is that the high resolution of those images. These images are done with a fairly high resolution camera, and when usually for machine learning you can scale down an image to like relatively small size, like 500 times 500 pixels. Then here we can't do that because again the details that we're looking at, they are really small. When you look at the images here, you can see that they are also like when you zoom in, they can be also a bit hazy because of the movement of the drone itself. So the high resolution must definitely be preserved. We have to be able to check for small spots like bird poop on those images. We have to be able to see small chips there. If there's like some charring on these insulators, and also there are a lot of different types of them. So I think in the project that we're doing, there were about 30 different types of insulators and 15 type of different faults each insulator can have. So that's a high level of differentiation that system must be able to understand. It's also important that the system can't work in a live environment, because when we're talking about flying with drones over vast areas, then the connection isn't good enough to actually do the machine learning either on the drone or transfer the images directly from the drone. So what's going to actually happen is that you take a lot of images, or like a lot of people take a lot of images, they get back home and then they upload those images and want to get the results as fast as possible. So it's like most of the time the system has no load, and then suddenly it's going to have a lot of it. And as I said, there were about 15 issues, different issues that an insulator can have, like different, like it can be broken or bent or charred or contaminated with different things or chipped and so on. And because some of the issues are like, you could even say that most of the issues are quite rare. And they're very varied in the sense that if you have bad wiring, meaning that the wire connection to the insulator is bad or broken, then there are a lot of ways it can be bad or broken. So like you have to catch the variation. And in our case, this meant that we also need to do a lot of augmentation on the images. So when we're talking about having a high amount of data already, then with augmentation, I think we'll multiply it at least 10x, but probably more in many cases. There were a lot of different iterations we had to do with the augmentation as well to see what works well and what doesn't. So what it all sums up to is that there's a lot of data, a lot of things to try out. A high number of training iterations. And because the model has to work on higher resolution data and work on different scales, then the model is also fairly complex. So this means that in the end, it's kind of impossible to train this model on, like, let's say, normal resources with any reasonable expectation in time. So how initially the training workflow that we used was that we only have this upper part where there's a workstation. We test the workflow. The place where we usually test the workflows, or where we train a lot of models, are the servers that we have on our own premises, which we use for most of the machine learning work we have. But on these machines, the training started to take months, and this is absolutely not feasible, especially in the testing phase of the system. So what we did was we used our own servers just to understand if, like, the workflow, meaning the machine learning scripts pre-processing the data, augmenting the data, and training the model, if these all work. So you test this out, you see that it works on a small sample of data, and then you schedule a training job and scale this up to as many machines as you like. In this case, what we did use Google Cloud for this. Why not AWS? Because Google was cheaper on GPUs. But when you look at the process, then you take the data, you scale up a training job on multiple instances on 8 Tesla 800s. This is a classic HPC job submission process. So with 8 Tesla 800s, of course, you could scale higher if you wanted to, but in our case, this 8 GPUs took us to a week of training, which is a completely reasonable amount if you do iterations on different approaches. Now, when you think about it, then actually, one week of training, I think that's even less than 200 hours. But I think the only difference with using an HPC would be that it would actually be cheaper. But at the time, we weren't aware that this option was on the table. And the inference workflow, the issue with that is that, as I said, that it's highly variable load, and when the load comes, it has to be solved fast. That one we solved with AWS, simply because the solution there was a bit easier to use. But again, files come in, we process them into job descriptions, and we submit the jobs one by one to AWS batch, which is basically, again, a scheduling system, which scales from 0 to whatever number you need quickly, and processes the requests. So basically what we did here is that when a user comes in, they upload thousands of images to S3. There's a small function that creates a job description saying that these, for example, these 10 images or these 100 images go to job 1, job 2, job 3. They get loaded on a GPU-enabled instance, which does the inference on a smaller amount, and then gets deployed. Then the results get stored in a database. What this means is that this is especially important for this highly variable load, that you don't pay for the machines while they're just running. You only pay for the resource when you need to use it. And the results is that the model, the result of this project and this general approach is that you get a working AI system that's feasible to maintain and integrate into existing workflows. And what we mean that feasible to maintain is that when I said previously that it's a human-in-the-loop system, it means that there's constantly data being generated for the machine learning models, which means that the model needs to be retrained every once in a while. And if you have to wait months on each iteration, it kind of means that you're constantly training models, and if something goes wrong, then fixing it takes a lot of time. So scaling this up fast, training the model quickly, getting the results, seeing how it performs, and also being able to integrate this into the workflow so that people can actually work quickly with the data in the process that they're used to be working in is super important. And without being able to scale out to just such like large on-demand resources, these kinds of systems are quite impossible to build. So yeah, with that I conclude, and thank you for your attention. It was a quick overview, so of course if you have any questions about the details, then I'm very happy to share those with you.
Right, so hello again, my name is Dan. I'm from CSE, so IT Center for Science here in Finland, where I work as a partnerships manager and responsible for industry-facing HPC and ICT services at CSE. So really good to be here this morning with you. Thank you for the opportunity, and the contents of my talk today is going to be kind of about AI-driven innovation and EuroHPC industrial use at CSE. So what I kind of intend to share with you in this session is our perspective on HPC, and especially on the LUMI supercomputer through the lenses of business, if you will, and where we expect this to be heading in the near future. So, but firstly, perhaps a little bit about CSE. So we're an ITC center of expertise that's owned by the Finnish state and higher education institutions, and we provide high-performance computing resources to researchers across Finland, and connected supporting specialist services for research. And this we do for Finnish education, culture, public administration, and also industry. And you could say that nowadays it's almost impossible to graduate from a Finnish university, well, not impossible, but close, or higher education institution without coming into contact with some of our services. And we provide these services to our owners at a non-profit basis. So turnover was about 56 million euros last year, and there were 500 of us, and we're located in the city of Espoo, very close to the capital, Helsinki. And so CSE, so talking a little bit first about our national infrastructure, and then we provide several different computational clusters. So we have HPC systems, and we have large storage and high-speed networks to kind of facilitate researchers when they come in at almost any level, whether it's running massive simulations or just single core jobs. And we provide things like data management capabilities, and we have a large suite of applications to support as many researchers as we can within this. So right now we run two national systems. These are national systems, Mahti and Puhti, where Puhti is a more general purpose computer at 1.8 petaflops. And while Mahti is designed for more massively parallel jobs that require peak performance at 7.5 petaflops. And Allas is our set-based object storage. Right now we have. But right now we're obviously very excited about the next system, which will soon be up and running in its full glory. It's actually partially already up and running, and it's called LUMI, and it's a so-called pre-exascale supercomputer. So CSE is hosting one of the EuroHPC world-class supercomputers, and we're participating together with a group of countries to acquire, build, and deploy this world-class computing and data infrastructure. So, and Estonia being one of these countries. But first, perhaps a little bit about EuroHPC. So really quickly, so EuroHPC dates back not that long, actually, a few years back, when the European Commission was kind of awakening into the fact that Europe is lagging behind China and the United States, Japan, when it comes to this tip of the iceberg supercomputing capabilities. And today, the EuroHPC declaration has been signed by 32 countries across Europe, including also associated non-union countries like Norway and Switzerland. And the program has been starting up at quite a fast pace, in the sense that already in June 2019, EuroHPC was able to announce the first generation of the supercomputer systems and where they would be hosted. So there's going to be 3 of these leadership flagship PSL supercomputers, one in Italy, one in Spain, and one in Finland, with the LUMI consortium machine hosted at CSC. And then in additional 5 petascale supercomputers elsewhere in Europe, and there are plans for a second generation of systems somewhere in the 2024 timeframe, and even the next generation a few years after that. So LUMI is going to be one of these EuroHPC pre-exascale supercomputers and physically located at CSC's data center in Kajaani, Finland. It's about 600 kilometers north of Helsinki, and the machine is hosted by the LUMI consortium, consisting of 10 European countries, and so you can see the countries here on the screen, and we're very proud, obviously, that so many countries with really credible national infrastructures, like the one in Estonia, were willing and ready for this joint effort. It's quite unique. We think it's no longer about owning the supercomputer, but really about using them. So that's kind of the background story. So the procurement is finished. So this is the HPE Cray EX supercomputer that was announced in last October, and with the capability of exceeding 500 petaflops, 550 in peak performance. And you see here how this compares to the current top 500 champion Fugaku in Japan. I think this is still true, and it's quite a nicely engineered system. We can pack the whole computing capability on the size of a tennis court, so basically 150 something square meters with less than 3 meters high cabinets. And to support this vision, so the technology, then the GPU accelerated computing and the GPU partition of the system. So LUMI is going to be equipped with or is equipped with AMD EPYC CPUs, and that's actually already there up in Kajaani. And then Radeon Instinct GPU accelerators. So in this generation of accelerators is going to be the new MI250X GPU, and that's coming online during it's being installed early summer, I believe, and most likely it's going to be production ready after the summer. So it, as far as I know, it's going to be very similar to the up and coming US flagship exascale system Frontier, which is underway, being so at Oak Ridge National Labs in the US. And so this is obviously a very exciting tool for academics research, but how does the business dimension connect to this? So the Commission has the ambition to expand the use of HPC, not only for science, but also for European industry and business, in particular for SMEs, and then also for the public sector. And then to support this, the new EuroHPC supercomputers can dedicate up to 20% of their computing time for commercial use. So this covers both the Commission share and the consortium share, and by extension also the Finnish allocation. And since the LUMI system will have up to 20% of its capacity allocated for industrial use, then what can we do for business? Well, here on the upper left is this kind of, we think important point, which is that we hope and expect to see more collaboration between academia and industry. So more co-innovation, if you will, co-innovation projects, where we, in addition to LUMI itself, can offer quite a wide range of competence in HPC and data management. So Euro, the competence center, the Euro EuroHPC competence. There's one example of that through through which companies then can sort of ask and be given support, and this should at least in some time frame reset, and for companies, the end result here would result hopefully in improved revenue streams. So what we expect to see is faster and improved research and development cycles through HPC. And here I probably should mention that we're really focusing on starting supporting R&D. So once the company case is finished with the prototyping, we will not per se, provide capacity for production runs. But like in the earlier company case, then that was interesting to hear. Then especially the fact that moving workloads around is not per se a problem. Then really what we sort of kind of are aiming for is that special things that companies want to try out, which can be kind of costly as well. That these would be that this platform would enable companies to do so. And kind of sort of get new things that perhaps weren't anticipated originally, and perhaps weren't budgeted for as well. For SMEs, then of course budget always an issue, and here we sort of think that this could be a sort of good opportunity for companies to go outside of the box and try new things out. So AI training is one thing that springs to mind here. Obviously, I'm going to talk a little bit more about that. So yeah, and as shown in the previous slides, then LUMI is going to be a very powerful environment for computation. We also expect computing to be really cost efficient, even though core hours for companies will be priced at market prices. And then the advantage that data stays in Finland. That's the case in the national case, obviously also in the other European case, and also world-class network connections, FUNET nationally and internationally through GIANT, which interconnects Europe's national research and education networking. So to the business use and how to get involved. And regarding partnerships and funding opportunities, then here are some of the channels that companies can use for getting access to the EuroHPC and LUMI resources. So we kind of had three service paths, if you will. The first one is kind of geared at companies that collaborate with the university, and where the results of these collaborations remain in open domain, so either publications or open data. So in this case, the LUMI 80% capacity research portion will be consumed, and there is no invoicing per se. And a few years ago, we had a quite successful co-innovation effort. It was called SEMTech here in Finland. It was coordinated by VTT, so that's the Technical Research Center of Finland, and funded by the predecessor to the Business Finland organization, TEKES, where we had a number of companies. So ABB was perhaps the best known of them, and then a number of universities also participating around FEM modeling and electromechanics, and that's one where I can sort of put the link if you're interested in Google. It was one of these things that we really did in collaboration with industry and academia, which turned out pretty nicely, we think. So that's kind of an example. So the next one here, that's connected to public innovations, a bullet point, and research activities. So for instance, commission-based opportunities within the Horizon Europe program. Examples here are Fortissimo for EuroHPC and the Praise Shape program, and Sakari Soini is going to perhaps mention a little bit about the Praise Shape program in his talk, and EuroHPC joint undertaking benchmark and development access, course of which I have a separate slide on the other, and then also on the other hand, national opportunities through Business Finland. So we've collaborated with Business Finland, and in Finland it's an important funding organization, in particular with AI, with something that's called the AI Business Program, which run for a couple of years. I think in December last year, where companies had the opportunity to connect computing resources to conventional funding grants, and I'll show you an example in just a few minutes. And we have Groke Technologies participating today, who is one of the companies receiving computing time under this program. So capacity in this path is really dedicated to projects. There's some invoicing capacities prepaid. And in the case of the AI business program here in Finland, and the maximum award was 80,000 euros per project over typically 6 months. And I mentioned that the AI business program has ended, but we expect new programs with the option of attaching computing grants to the projects. And then finally, there are plans for direct paper use with invoicing at market prices. These type of cases we aim to steer in the direction of joint undertaking here in Finland. I think that perhaps you guys in Estonia are going to do it a little bit differently. We expect that the number 1 and 2 pathways will consume most of the Finnish LUMI industrial 20% share. We'll see about that. About the pricing, we don't yet have the final pricing confirmed, but I can sort of give you some ballpark figures. If I think a node hour on the CPU side would be something like 57 €, and that's 128 cores in the node. And on the GPU node hour, it's going to be probably the ballpark of €2.20, and that's for GPUs. But these are ballpark figures. I haven't seen them; they haven't sort of been confirmed yet. So, but eventually they'll sort of pop up on our web pages, I'm sure. So here real quickly about the development calls. These are also interesting for Estonian businesses. So these are calls where the applicant can come from both academia and industry, and the application can be really targeted towards all the EuroHPC machines. So not only LUMI or any of the pre-exascale machines, also there's smaller but not small machines in the EuroHPC ecosystem. So a company from Finland or Estonia can apply for access not only for LUMI but for any of the machines in the EuroHPC roster. And a concrete example here is a company called Northvolt from Sweden. So they make batteries, and they were awarded time on the Vega system in Slovenia. I think that was really the first system in the EuroHPC line that sort of came online in production. And I believe this company was really the first industrial company to be awarded time on this from the EuroHPC industrial share. And they got some 2 million core hours. So you can find information on that on the EuroCC web pages. So they got 2 million core hours. And this is a new mechanism. This is something that we really would be keen to try out with interested industrial partners. So if this kind of raises interest, then please contact me or Ülar. So finally here to show you a little bit what type of companies we kind of expect to apply for computing time on LUMI. Well, so I have here a number of companies that were partnered with us at CSC today. So many of these have been traditional HPC cases. So computational fluid dynamics. So structural mechanics. You see ABB Kone is the elevator maker in Finland. And such. For Nokia, we did acoustic simulations for many years, and computational fluid dynamics is still very popular in ship design. So we have a couple of 4-ship and Delta Marine, 2 examples of those kind of applications. But and so on. But you could say that the GPU computing as such has increased really sharply at CSC. We've actually had historically pretty limited GPU capacity until early 2020 with the new Puhti system. Then things really really took off, and LUMI is of course going to completely change this picture. So at the bottom row of companies, at the bottom row here of companies that kind of represent machine learning related cases, we have Disior, and Sakari is here today. And Groke is going to talk about these, and we have a company called Inscripta, and these are examples of really AI cases. These are, in a sense, really our first industrial AI cases, at least in a large scale. And good example of the cases that we expect to see in the near future, and further on with LUMI, and these cases have received funding through the channel shown here on the slide. So I think I'll stop here, and my time is out anyway. So this was kind of a tour how we support company R&D at CSC and what we're looking forward to be able to do in terms of industry support in EuroHPC in the very near future. So thank you for the attention. And now I suppose over to Sakari from Disior.
All right, thanks, and always nice to be here in the supercomputing. Even there, feeling a little bit superhero by myself also. And I'm Sakari Soini. I'm one of the founders of the Disior and also CTO. And we have been playing together with CSC quite a long time already. And as Dan mentioned, we were part of the SHAPE, and then also during our Nokia time, we used to use the Elmer in our acoustics calculation, and even before that, as yesterday also discussed with Dan, we use Elmer in paper machinery there where I used to work in the Valmet, and thanks for participating. I put something here myself, and this our team when we started this year will look like this, and now like this. So 5 years in the startup world is not it makes it, but we have had a great time there. What we do. So we have been developing medical image analysis software, and we are this kind of we are deep tech system. So in fact, what we do, we turn medical images into mathematical format. So there is a 3D imaging modalities, there's a computer tomography, magnetic resonance, and cone beam computer tomography stuff. But they are just images. But what we do, we turn them in the mathematical format where you can easily measure, modify, do all the mathematical stuff what you need, get all the angles what the doctors are needed, and that is our core stuff there. We have been there from now 6 years. We have been doing quite a lot of also thinking that we are startup, that have been startup companies. There also scientific research, because in the medical field you need to be you need to have this kind of science evidence, because doctors want to be really sure that if they are using something, it's really it really work and it is proved to be efficient, and that's why we have been doing a lot of science as well. After there lately happens that in fact we made what we call in startup phase a word exit. So we sold our company to Baracon 28. It's a US company, but still continuing what I will show a little bit later how our story continues inside the Baracon 28 as such. These are our current products what we have been doing. So our main product has been this foot and angle. So this this figure so analyzes surgical planning for foot. The other is for hand and wrist, the same stuff, and that we have classified as a CE class 2B, which is reasonably high class classification, and the FDA class 2, which is also quite high. So CE marking means that we are able to sell those products in the sell the product in the European Union area, and FDA that we are able to sell those in the America, US there. And they are one of the leading analytic software. The other what we have is this kind of craniomaxillofacial orbital. So this eyeball area analysis for that, and there we have a only CE class 1 stuff there, and there you can analyze about orbital fractures and so on. Then we have also, that is not very well known, but we have a new neuro. So we also do anatomic segmentation and find this kind of tumors from brains. That is also quite a small classification. It's class 1, and we are doing that together one Netherlands company, and we are doing the engine there, and the Netherlands company is doing user interface, and they are also selling the program there. And in fact, our fifth program is the head and neck. So that is non-medical, that is sold only in the US there, and it's used in the chiropractics to see about the neck failures and neck position and that kind of. This quite common, in fact, in the US. If you have ever seen that, if there's a if you are driving with car and somebody hit your car from the backwards, after that, well, there's at least in the movies, there come a lawyer and ask, do you want to sue the other one guy because your neck is now broken? And that is used there, but it's not a medical, so it doesn't need it to be medically approved. But these are the products what we have been doing there. And what to do with those? In fact, this is the system as a whole. So pre-op image, so this means pre-operative, so before the surgery, then see what is the problem. Then there should be this kind of plan for optimum fixation, so how to make the operation. Then do the operation according to the plan, and then see what is the outcome. And after that, collect the data, and then that can be used in the designing more efficient treatment, more efficient and better tools for the operation, and so on. And that is what we did. And there is needed also a lot of cooperation and cooperative partners. So we very soon learned that it's not enough to be in the Finland, and not even in Nordic countries, and you have to go outside and US and Europe and seek for this kind of key opinion leaders and start to cooperate with those, because they are the guys who are then saying, and those other doctors, they will ask from those top-notch doctors, hey, is this your software, is it worth of anything, or should I use it, what I should do it? And those have been also very important part of the story. So keep and get the trust of some key opinion leaders. And in fact, I have to say that CSC is also part of that story, because this is the hypercomputing, supercomputing, and it has very nice gling in the even the doctors understand that it's something special, and that is the one reason we are also interesting to be together with CSC, and we have gained some benefit out from that. And that is what we did in the Disior there. And now we are part of this Paragon 28, and I will show what happens next. This is something we want very much to cooperate with the CSC, and we will have there something special ongoing. You will find this presentation, if you are interested in the web there. It is www.smart28.tech there. And in fact, this is our team as such, what we will start to do. So pre-operative planning, now we will mostly concentrate on the IE technology, and that is something where we are very much waiting the cooperation with the CSC and also waiting for the LUMI system coming there. It will create, and there's a possibility to create something really big and interesting stuff there. Also then the intraoperative support. So during the operation, there's a lot of things what we will do, but first we need to keep the baseline. So the image, the bone structures, and this AI system what we have been now developing, we have gained very promising results from those. Unfortunately, I'm not able to show those, but it gives our confidence to continue in that area. And there is a technology such as detecting the severity of the fractures and how it should be done. And then the other is then put those in the maybe what is for me most interesting in this kind of navigation and robotics stuff. And then again the post-operative, so collect the data and use the AI to put that forward and keep this thing going around there. And well, as you see, we were not just purchased to get the program, so our hand and wrist and foot and ankle, but also doing something and continuing the development there. And we are doing much research projects with the doctors, and as you see, we are publishing together with them also quite much as such, and commercial, and then the outcome optimization. And so in the exit, our story, I would say, is not ended at all. I think we get really big boost from that, because Disior is a software company. We are concentrating only in the software, only in the analysis, but this Paragon 28, it is a hardware, so it is creating implants, those titanium plates what are then screwed on the people's hands or foot or ankles to get them ready. And that is where CSC has been also part of our story, and we would very much like to continue and even go deeper in that, because we know the benefit for this kind of supercomputing and high-tech stuff. And well, I'm Sakari Soini, and anything you want to also after that, please contact us, my email and so on.
My name is Antti Lehmussola. I've been working for a couple of years now as a team lead for machine learning in a company called Groke Technologies. The title of my presentation is Autonomous Navigation Solutions. Actually, I'm maybe talking about basically our kind of a road towards autonomous navigation solutions. So we are heading towards that, but we are not yet there. So I'm from the company called Groke Technologies, which is a 2.5 years old company, focusing on developing intelligent methods for autonomous navigation. It was founded 2.5 years ago in collaboration with Mitsubishi Corporation in Japan. The company is Finnish and located in Turku, but working tightly together with Japanese maritime industry. The founders of the company are from the Rolls-Royce ship intelligence unit that was located in Finland, but then moved away. So the people founded this Groke after that, trying to utilize their expertise in autonomous navigation. So the main idea of the company is to improve the navigation in sea, and the first focus point of the company is to develop navigation solutions for the Japanese market because of the Mitsubishi collaboration, and especially in Japan they have this very kind of a strange situation where, well, first of all, they have huge amount of vessels in Japan, but the average age of a Japanese captain is more than 50 years already. And in Japan, they are not allowed to sail under Japanese flag if they don't have a Japanese captain. And basically what is happening is that they are running out of captains. And as a one solution for that, we are now building kind of a modern technology to help the navigation in Japan, to help to extend the working time of these older captains, but as well to make the sailing and maritime industry more interesting for the younger generations by introducing higher technology. So, well, mainly one of the biggest goals is to kind of reduce collisions, for example, at the sea. And as with many systems used by pure humans, you are kind of facing problems with bad decision making and unexperienced users and lack of communication and fatigue, and also in this case problems with poor lookout and especially problems with radar use. So a lot of challenges in the navigation, and those are such that Groke is trying to solve by building this kind of a multi-sensor system unit to be installed in vessels that uses a lot of different sensors to improve the navigation. The overall goal is to do autonomous navigation and of course get rid of the human. But before getting there, there's a lot of things that can be done already with kind of improved perception and improved visual awareness and kind of building a awareness system for the captains and operators of the vessels. So what we are building, like I said, is the multi-sensor system that uses different sensors like radar technology, AIS technology. AIS is a kind of a radio transmitted messages that the vessels use to tell other vessels where they are and where they are going and what is their ID and how big vessels they are and so on. And then we are using camera technology. We have a kind of daytime camera and then a thermal camera, and using machine learning and for doing object detection. So we are detecting vessels through cameras and identifying, classifying them and tracking them. And then other technologies like IMU for our position and GNS positioning, and then C charts, and combining all this through sensor fusion technology for the user on board. And it kind of the left side here shows the current situation where the operator basically has only some location-based technology and maps, and then possibly a radar and his or her own eyes to see what is happening on the sea. So this is what we are doing. Multiple sensors fused together. The AI part and the machine learning part is mostly currently focused on this processing of camera images and the object detection part, but in future more of these sensor modalities will be also handled through machine learning. But right now our focus and my focus has been in this part. This shows in more detail what we are building. So we are right now in the product development phase, building this system and hopefully getting it out soon for the customers. The idea is that we have this multi-sensor system installed on the vessel, hopefully somewhere with a clear visibility, and then we have a separate computing unit on board that handles the data flowing in from the sensor system, and then we have user interfaces for the operators and so on. And like I said, that currently the machine learning part is mostly handling the camera view that we get, and it looks like this. So we have a camera unit here, and we have one visual camera that is has a very wide field of view, 225 angles, and then we have a thermal camera with 180 degrees field of view. And we try to process this data coming from the camera and identify and detect all the objects around us and classify what are those, and then providing that information downstream for further processing. So basically what we are trying to do is identify that here you see a tanker, here is a cargo vessel, here is a fishing vessel nearby, here is a sea mark, and so on. And then providing the information for the user that you have to be aware of this. And then the user interface looks like this. So the user is able to view its surroundings and all the data in the user interface, providing the situational awareness information. And here's just short roadmap for the development. So main idea is that we start with the perception system and situational awareness, and then move towards more autonomous navigation. But with the situational awareness, we already believe that we can help a lot these captains. So then going to the machine learning challenges that we face, and the challenges that we are now also trying to solve in collaboration with CSC, as Dan mentioned. So we are part of this Business Finland AI grant and using CSC resources for training our models. The main thing with machine learning and with computer vision is that basically we are building deep neural networks for object detection, and we are trying to find the optimal trade-off between the accuracy and performance of our models. So the view is something like this, you can see here. So there are lots and lots of vessels that we need to detect, and then we need to classify after that where it might be that the image has kind of a bad resolution, but you can see here small vessels all around, and especially in Japan there can be tens and maybe hundreds vessels in the same view that we need to detect. And there are a lot of trade-offs in the machine learning side that we have to do in order to find the optimal performance. And for that we use CSC machines to do a lot of kind of a searching for the optimal solutions. And of course, one thing is that we need to do all the inference of the models on an edge computer, so we don't have a lot of resources to do the detections. So what kind of problems we are trying to solve? So finding this trade-off. So first of all, when doing object detection, you need to have a suitable architecture for your model. And there are basically hundreds of different machine learning architectures available for object detection. And there is like no lack of research going on, but maybe the problem is that there are so many models. And for example, here's just a list of this common YOLO family for doing object detection. You have like YOLO 1, YOLO 4, YOLO 3, YOLO 5, scaled YOLO, PP YOLO, and so on and so on. Basically, every week someone claims to have published the best model available. So we need to find the best architecture for the model. The best architecture is such that it's kind of able to run in a edge device, but still have a decent accuracy for the model to work in real time. We have to also deal with a sufficient input resolution for our model. So basically we have very high resolution cameras, but the problem, of course, is that higher the resolution is, the harder the computation becomes. So with very high resolution images, we are able to detect very small objects, but in the same time, it takes a lot of computing power for the neural networks to resolve that. So we can use high resolution images with simple networks, but simple networks are not the best ones. But if you use complex networks, we are not able to use that much resolution. So there's one trade-off. Then we have to do efficient training with minimal amount of annotated training data, because this kind of images that we use and see, they're not that much publicly, for example, available, and it's not that easy to collect data for our model. So basically we have test vessels sailing around, especially in Japan, collecting the data for us, but we have to handle also the annotation and pruning of the data and so on. Then we have to find the correct hyperparameters for the models. So we have to find the best possible model with the right hyperparameters. And then when you're talking about computer vision and object detection, this image augmentation plays a big role. In case if you don't know what is image augmentation, it's a way of kind of extending your training data by simulating error sources and different types of variation in your true data. So you pick one image and then you simulate lots and lots of new images from that one image to cover lightning conditions, noisy images, bad weather, and whatever. So you have to do a lot of that, and all of those augmentation methods have their own parameters. So the parameter space of everything is huge. And for that, we have to kind of search for the best solution. And here are some examples of kind of edge cases that we have to deal with and we have to solve with our computer vision system. These are daytime images, but we also deal with thermal cameras. So first of all, often in computer vision, you might be interested in objects that are pretty much have the same size, but in our case, we have to detect targets very far. So for example, here is kind of a very distant object that we are detecting. And actually this is, I guess this is the kind of the furthest object that we have successfully detected in our training data, that we were able to measure that how far that is. So this is a kind of a big C mark in near Tokyo. And you can see that it's really, really tiny, but our model was able to detect that. And as you can see that there's not that much information available, and it's actually 10.5 kilometers away in the horizon. So there is a lot of objects available in the image. But in the same time, we have to also detect very close by objects. So maybe this is the edge case. We probably wouldn't have to actually detect this one, but I was happy to see that our model was able to detect. So this is kind of a right next to a side of another vessel, but it kind of highlights the range where we operate. So a vessel can be as near as right next to us, but it can be also 10 kilometers away. So the model has to handle that. And the visibility might be really poor. Of course, in this case, we didn't detect anything, but while you are at sea, you have to handle rough conditions, and also you have to have data from rough conditions, and there are many variations for that. As you can see that we are not able to see here anything here actually, but anyways, it's just an example. And then sometimes the situations might become quite strange. For example, here we were able to detect the vessel correctly, and we actually labeled that this, when we analyzed the result, that there's something wrong with this because there are some other vessel too. But actually then we noticed that basically it's a kind of a correct detection. It was a vessel inside another vessel. But all kinds of strange things can happen in real life that we have also to handle somehow, because we are not, it's difficult to know when something like this happens. Okay, that was actually everything that I had prepared for the day, just to show you what we are doing and what kind of the things we are dealing with.
If you have any suggestions on how in general we could help businesses like yours, that's also interesting for us. But if you have specific requests, then of course just contact us and we'll try to support you. As Dan mentioned, 20% of LUMI is dedicated for company use, and that's a lot of capacity, and we would be happy to help you use it as easily and efficiently as possible. Of course, we have some boundaries or constraints of how much manpower we can invest on every researcher, but we'll do what we can, and we definitely will try to help.